All right, welcome to the Actuarial Technology Summit 2025. This session is What if Actuarial Modeling Software was invented today? And welcome to our live audience at Purdue University. So my name is Igor Nikitin. I'm a CEO and co-founder of Nice Technologies. I'm also an actuary and a software engineer. Prior to my current role, I have worked at Prudential Financial and Pacific Life, mostly on pension risk transfer and longevity risk transfer business. A lot of actuarial modeling software that we use today was originally designed in 1990s. This presentation will explore the changes in the environment that took place since then, the effect of those changes on desired properties of the actual modeling software, and ultimately consider what would software look like if it was designed from scratch in 2025. So first, let's consider the environmental changes. And we can group them into four categories: technology, data, culture, and regulation. So technology deals with kind of hardware of things and the capabilities that brought to bear. The data deals with the amounts of data and the types of data that were not available back in the 90s, but are quite readily available today. Culture is more the shifts in the workforce and the shifts in how we actually work as actuaries. A lot of us no longer have a desk with a bunch of drawers and a bunch of papers. A lot of us are working remote, and that has not been the case in the 90s. And finally, the regulation. So right now we are getting ready for VM22, and we have IFRS and Solvency II, which are far more advanced regulatory frameworks compared to what we used to have. So the technology environment has shifted very dramatically. We no longer have computer towers under our desks. We don't have server rooms, and most of us don't have phone on our desk. Everything become very mobile, very lightweight, and a lot of the compute power have moved to things like cloud, where you don't need to have it on premise anymore. So compute power has advanced not only through faster processors, but also through cloud technology, GPU parallelization, and you can do so much more computations nowadays compared to what you used to be able to do. We can do it relatively cheaply, and we no longer need a PhD to spin up a grid of a few thousand PCs. You can just click a couple of buttons on AWS and you have that. There are also massive advancements in open source ecosystem. So if you need data visualization, documentation, quality control, you name it, there's an excellent open source library for that. What's even better, those open source libraries are often the best solution for that particular task. It makes it very similar to kind of car parts, where instead of one manufacturer producing all of them by themselves, it is much better to just go to specialized manufacturers who do tires or engines or transmissions because they can do it better and cheaper than each individual car manufacturer on their own. Uh, there are tools for machine learning and AI that are, first of all, free, and second, it is amazing how advanced those tools have become, and how easy it is nowadays to do advanced machine learning with sklearn, for example. It is literally just dozen of lines of code that takes care of basic machine learning. There's modern development tools such as Git, Visual Studio, DevOps that were perfected over the last few decades to become amazingly robust. And community has helped develop plugin extensions for their functionality to quickly embrace emerging technologies to be able to provide tools that the vendor perhaps did not have the capacity to build, as well as provide creative use cases for various applications to help developers do their work much faster, easier, and quicker. Uh, One thing to keep in mind is that with all of these technological environment advancements, this is certainly not done, and there will absolutely be more of these technologies coming out in the near future. So, if you recall, like 10 years ago, it was all about blockchain. Blockchain was all over the conferences and it was top of everybody's mind, and everybody was trying to figure out how to use blockchain. Today, it is generative AI. It is a little bit broader technologies than a blockchain, but the point remains that it is a good tool for certain use cases, but it is not a solution to all of the world's problems. And soon there will be quantum compute and other technologies that will take place of generative AI and add to our toolbox of solutions to our compute problems. So next, let's consider data environment advancements. I don't think it would surprise everybody that now we have more data than ever before. And the volumes of this data keep increasing at staggering rates. So the problem became it shifted from we don't have a data for that to we have all the data, but how do we extract the insights out of that data? And that's what led to the rise of data science as a profession. The data now is much more varied too. So we have information on health from wearable devices. We have locations from cell phones. We have geo services from Google. And I recently even learned that there's a company that works on data based on what people actually eat and the implications on mortality from that data. So it is no longer just structured data of tables and numbers that we used to have. It is now very granular and very diverse data. And the challenge shifted from where do we find data to how do we use relevant data? How do we extract insights out of the data? And how do we integrate data from multiple sources to gain insights into mortality and other business relevant applications? Our culture has shifted quite a bit as well. Part of it was a result of COVID-19. And during COVID, obviously, there was a lot more remote work. And a lot of companies, even that did not have remote capabilities or their remote capabilities were very limited, have managed to solve that issue and provide remote capabilities that were almost as good as being in the office. Video conferencing became not laggy. Sharing files became convenient. And connectivity and security of those connections have come a long way to the point where working remotely now is as commonplace as working in the office. So the consequence of so the other major shift is that back in the 90s, people tend to work a lot longer at a single employer. Versus nowadays, if you go on LinkedIn and you look at resumes of people, you will notice that majority of people change their jobs every 2 to 3 years. And it can be between companies, but it can also be roles within large companies. And those roles can be very different, especially for actuaries. So the consequence of that mobility became the desire for transferable skill set. In other words, it is very frustrating to come to a role, learn some specific actuarial software, just to leave that role a year later um, and be required to learn a different software that looks completely different, operates differently in your new role. Um, Now, the flip side of that is recruiting for those roles. It is also very splintered, and it is actually surprisingly difficult to recruit people proficient in specific software. Uh, the other shift is learning, what I call learning overload. So basically, it's an idea that there are so many different things to learn nowadays that even picking a skill to learn has become a challenge. A common problem is something like, well, if we want to use AI, for example, well, which AI should we use? There is Google, there's OpenAI, there's so many choices. And it goes, it's similar problem with a lot of technology today where there are so many choices and it becomes very difficult to become an expert in those and to understand what are the differences between those choices and which ones will become more relevant or less relevant in the future. On one hand, it became easier to learn with things like YouTube videos, AI, and there's more channels for learning new information. On the other hand, it became more challenging to separate credible information from not so credible information. So a prime example of that is learning from AI. It is sometimes possible to learn things that are completely wrong because AI sometimes is just doesn't provide good information. And same goes for the social media. And last point on learning would be that the depths of the technology have increased substantially. And so to become an expert on some library in the 90s versus becoming an expert on some library today has become much more challenging just because there is a lot more features and a lot more functionality and a lot more sophistication in the technologies that we use today. Um, the other shift is collaboration. So it used to be possible to do actual modeling with a single person. And the flip side of that is that there is complexity limit of how sophisticated of a model can you build with just one person. Now, if you want to build something with multiple people, then you would need an infrastructure that supports collaboration between those people. They need to be able to organize their work, to split their responsibilities. Ultimately, they need to be able to peer review and merge their code. They need to be able to collaborate in such a way that it is easy to add the components together without having a separate project of how do we now merge the functionality that was built by multiple developers. And the last thing I wanted to talk about on culture and workforce enhancements are advancements in programming. So programming syntax has become a lot easier to use. We back in the day we used C++, which required quite a bit of understanding of various hardware points of how computers work, right? But then we got IntelliSense, and that became easier. Then we got higher level languages like Python, and that made it easier. We got libraries that make it even easier. And nowadays we have AI where if you can describe a problem, it'll actually take care of the syntax for you. So it became much more accessible to professionals and in particular to the actuarial profession, chiefly driven by the fact that programming was added to actuarial exams back in 2018. And so younger generation of actuaries are actually do actually have a background in the basics of programming. And that is a very big shift. Last, I would like to talk about regulatory advancements. So more compute power led to the companies designing more sophisticated products. And that mainly went through the optionality that is being added to various products, right? So with that, that sophistication required more compute power. And with more compute power, it became feasible to actually do that in a scalable and maintainable way. And of course, that led to the advancements in regulation because it became clear that your factor approaches in like RBC, for example, they become very challenging for a lot of these newer products that are more creative and have more or different risks that are packaged in different ways. So today, one of the biggest changes is introduction of VM22 and the requirements for asset modeling. So, attending the conferences this year, SOI conferences this year, it was pretty clear that asset modeling is top of mind for a lot of actuaries, and they seek to learn more about that aspect of modeling as well as to have software that can handle that. AI governance and fairness is a new, well, it's sort of new area because granted in any assumption set and pricing, fairness is something to be considered. But AI governance is a new area where regulation is not quite there yet to define what should it be and how exactly should it be governed. So at the moment, it is a little bit up to each company to figure out what to do with that and anticipate the changes of that. Um, and the bottom line there is that the complexity of the regulation is increasing. And because of that, the need for sophisticated modeling and consequently sophisticated modeling software are more important than ever. Um, so let's now consider the properties of modern actuarial software. And we will look at it from several perspectives. And first perspective would be the technology perspective. So if we were designing an actual model and platform today, what properties would we want that software to have? First one would be using standard industry tools. So similar to car manufacturers, if somebody has an excellent tire or an excellent engine, it would make sense to reuse that, especially if it is open source and it is free to use. It would make it much more transparent. It would make it probably higher quality than anything that individual companies can build on their own. And it just makes sense because it makes it significantly accelerates the process of developing the software. Second quality we would want is probably a modular architecture. With the rapidly evolving regulatory and product environment, we would want to be able to reuse modules of our software and be able to apply them to more than one product. So, for example, if you calculate mortality, and you make a nice module out of that, it should work for annuities, it should work for individual life, it should work for a lot of actual applications because fundamentally it should be doing the same thing with some assumption variations, of course, but it shouldn't be completely separate. Next property that we would probably want is performance, because with today's regulatory requirements, as well as product sophistication, we definitely don't want models that run for days or weeks. We want something that gives the answer fairly quickly. And fairly quickly can be defined a little bit different depending on use case. So pricing would want something quicker because of the deadlines versus valuation. It's more established and it's it's a little less sensitive to runtimes. Next property we would want is integration with emergent technology. So when AI came out, right, how many of the existing actuarial software was able to say, oh, okay, great, we can just integrate that into our software in a matter of days and be able to use it to aid with model development, with documentation, with understanding the model, and all of the things that AI is actually pretty good at. And the answer there was that was actually a challenge. And we in a actuarial software of today, we would actually want to be able to respond to emergent technology quickly and perhaps even without the need to go to the vendor for that. There will be more emergent technologies in the future, as I've mentioned, like quantum compute, and so we want a software that would be ready to integrate with those fairly quickly. And last would be diverse support options, right? So as a model developer, you want to be able to Google answers to your questions. You want to be able to use AI to get answers to your questions. And this is very challenging to do in proprietary software just because there is so little information about it in the in the public domain, right? So there is no there some software have like a forum, for example, where you can ask a question, but because of the limited number of users, those forums they are often quite limited comparing to what you would see in the software development domain, like Stack Overflow, which basically had an answer to any possible question you could have. Um, so diverse support options is something that would be desirable as well. You want a software where you can just Google the answers to particular questions you have. The next lens that we want to look at is actuary perspective, right? So as an actuary, what would I want in a modern actuarial software? One thing I would want is reliance on transferable skills. I want to be able to switch roles or switch companies and keep more than product knowledge. I would want to keep, in fact, as many skills as possible that I was using when that I was using in my prior role, right? The next thing I would want is support and learning resources. So once again, I want to be able to ask questions quickly. I want to be able to use Google. I want to be able to use AI. And I what I don't want to do is submit a vendor support tickets and wait for a couple of days and then get an answer. Please read the documentation. And that can be very frustrating because by then I probably worked through the weekend and missed my vacation or something. So support and learning is very important. Next, I would want collaboration tools. So as the sophistication of software increased, right, I want to be able to work on specific aspects of the modeling platform, and I want to be able to easily split the development with another actuary or group of actuaries. And I want us to be able to see the progress of each of us. I want to be able to merge the code. I want to be able to have ways to quality control the code and ways to make sure that our code conforms to the requirements of our modeling platform, right? So that it's clear, for example, or it has documentation. So I want some sort of ecosystem that would enable me to have those things. Next, I would want transparency because there was quite a bit of a debate in actual community of open tools versus quote unquote closed tools. And I frankly think that that debate is kind of strange because it is possible to have a tool where you cannot modify, let's say, the calculations, but at the same time, you should be able to see what the calculations are because the amount of time spent trying to understand the black box is it's frustrating and it's a lot of time and it's not a good experience. So, if a tool was designed today, I would want it to be transparent. And depending on use case, I want to be able to switch between kind of view only or ability to modify. So for R&D, I want to be able to modify things. For valuation, I don't need to modify things, but I want to be able to trace through the calculations and understand what exactly is happening um, at various points of the calculation. And last, the tool needs to be flexible because, as we have noted with the complexity of regulation and complexity of products, that evolution up the complexity ladder is going to continue. And what I don't want to do is switch my modeling platform every few years because next regulation is not supported or not supported quickly enough, or the product sophistication became so great that it became very difficult to implement that on my existing platform. And last, let's look at business perspective. So from business perspective, what would be the properties of a modern actuarial software if I were designing it today, right? So first of all, it has to be cost effective because ultimately we're as a business, you are there to answer to your shareholders and you are there to generate return on capital. Uh, so for cost effectiveness, there's a couple of things to consider there. One, it must be the cost effectiveness of the entire modeling operation, right? So not just the license cost, but also how much time do my people spend on doing various tasks? How easy is it to recruit for the expertise that is needed for the software? Um, how efficient is it on cloud or other resources that I have to pay for? So basically, adding up the license cost, the people cost, the cloud cost, and the consulting cost, and looking at that cost holistically and saying, how do I minimize that? And how do I have how do I build a software that minimizes that as a package? Uh, the other quality I would want is abundant talent. So I would want software that relies on common skills that actuaries have. And that would enable me to hire much easier and quicker for the expertise working on the software, right? So for some of the existing software, the challenge there is it's very specific and very fragmented. So if you're looking for a developer for a particular modeling platform, there is only so many of them out there, and that search can be quite difficult, and you may end up paying quite a bit of money to find and attract the right person. So from a business perspective, I would want the software that relies on something that actuaries kind of learn through their training and something that they use day to day so that I can find, so that there's many qualified candidates out there and not just a very select group. Next, I would want reliability. And reliability can be described in several different reliability is kind of several different aspects to it. One is I want to be able to rely on the results of the software, so it needs to be very well tested. And how well tested, it depends a little bit on the size of a company and the use case. Obviously, for R&D, you cannot do same testing as you would do for valuation. Uh, but it needs to be doable. The testing needs to be doable as quickly and efficiently as possible so that even for R&D, you have minimal level of comfort with the results that you're getting. Uh, Second aspect of reliability is just having good error messages out of a software so that if I feed some unexpected inputs into it, be able to I want the software to tell me where those inputs are and why they're wrong, so that I can fix that as a user without having to dissect what exactly went wrong and how mechanically did I get division by zero. I want something like policy so and so has benefit amount of ABC and it should be a number. So I can easily kind of go and fix that and be able to identify those things quickly and hence run my software more reliably. And the last point is I would want to avoid key person risk because if I have only one person at the company who knows how the software works, then I run a risk of that person leaving, and then nobody knows how to maintain it, and then it becomes a big problem. So, whatever this modern software we design in does, it should not have a key person risk where only one guy at a company knows how exactly it works. So with these, we can then, okay, sorry, I see some chat. One second. I'm checking if there is any questions in the chat. I just noticed that there were some notifications. So question to presenter, do you think the actual talent being developed by SOA schools are adequate to even utilize this theoretical modern actuarial software? Uh, so I let's talk about that at the end of the presentation. I do think that there are indeed some things that could be done differently, and then we'll consider that shortly. How's the okay. So yeah, I'll address the comments in the Q&A section. Uh, so next, let's just brainstorm what exactly. So what could an actual model in software look like if it was designed today? So we know the properties that we want the software to have. So let's think about what could it actually look like, right? And the first point would be if we build it on Python, for example, and provide full access to underlying code. So that would uh, bring bring up a business model discussion, right? So majority of actual software today is SaaS, so you don't really have full access to it. And if we provide access to code, then there are two ways of doing it. One way is open source, and the other way is source available. So the difference is with source available software, only the clients get access to the source code, but not the general public. Versus open source, everybody gets access to the code. And so if we provide full access to the Python code in this theoretical software, then what problems would that address? Well, first of all, it would enable the use of common technology. It would rely on the common skill set. It would allow for support of AI, Google, and other readily available resources. Um, and it would In practice, it would operate kind of very similar to an in-house model, but perhaps with a better engineering and better standards comparing to just building it from scratch. Second things that we can do is it would integrate with existing and new technology. So instead of building custom interfaces the for code editing, for the DevOps, for the user interface. It can use common technologies like Excel for user interface. It can use Visual Studio for code editor. It can use Azure DevOps, for example, for the development process management and the ability to automatically test and deploy the changes. The advantage of that is that the amount of resources that went into each of those tools is likely as high, if not more, than the amount of resources that went into building a lot of the bespoke solutions that exist in the actual software world today. So similar to using Python and the libraries from Python, it's an idea of if we have an excellent component that can be used, then why not just use that component instead of building it yourself? Uh, Next thing we can do is having professional design. One of the comments in the chat was that it's not really writing code, it's the engineering that is the challenge. And I agree that engineering for actual software is indeed a much more complicated task. Knowing what tools to use, what architecture to use, how to make it all performant, maintainable, clear, and flexible, right? That is indeed a much more complex task that, frankly, AI is nowhere near to be able to tackle efficiently for our specific use case. So, what if there was a vendor that designed the framework for this and provided it to the rest of the market? So you get economies of scale there. You can have excellent engineering, documentation, and quality of code. And this idea would be quite new to the actual world. But if you look at video game developers, actually, they've been doing that since the 90s. They had very similar problems there, where as computer technology advanced and became much more sophisticated, the problem became is okay, we can make a video game with better graphics and release it again and sell it again. Great. But development costs skyrocketed, and the customers refused to pay more than $50 per game. So what they did, they came up with idea of engines, so Unreal Engine and Unity, where you can buy from a vendor the source code of kind of all the core functionalities that you would have for the game, how walls work, how physics work, etc., and then you modify that core into the games that you have. As a result, they've been using that business model for about 3 decades at this point, and our video games still cost $50 to $60 today, even so the sophistication of the programming that goes into them have increased very, very dramatically. And last point would be the support by existing knowledge, vendor, AI, and consultants. So one thing that this software should do is have a lot of options for the support. As a user, you want to be able to say, well, I can do it, or I can hire a consultant to do it, or I can have AI help me do it, or even do it depending on complexity of the change requested. Or I can go to a vendor and ask for some help. So you, what it would allow to do is to not have the development bottlenecks that a lot of existing software faces, where multiple clients ask for multiple changes, and that overwhelms the capacity of the vendor to address those changes. Um, and so, in summary, a software that would be professionally designed by a vendor, built in Python and provide full access to underlying code, integrate with existing technology to use familiar tools and interfaces, and providing broad support by vendor AI consultants and good old Google, would be something that would be the software that would exist if it was developed today and kind of imagined today. So with that, we are ready for questions. And I'd like to start with the questions in the chat. First one is a comment. In my experience, it was very disappointed by the code abilities that were exhibited by students that passed exam PA. I agree that coding is one of those disciplines where if you take a course and never do anything with that knowledge, then that knowledge tends to erode. And you very quickly come to a point where even basic loops and if statements are not something that people kind of notice or can efficiently use. So the solution to that is goes back to the standardization of the skill sets that we use as actuaries, right? So if there was a substantial amount of people in a market using software based on Python, right, then the skill becomes more valuable, which encourages the students and practitioners to be more proficient in it. And then it becomes more transferable, which makes it even more valuable. And then that is how that is, I think, how it would become increasingly more important. The other aspect on this, and I'll actually talk about that in another presentation later today, is if we compare actuaries to data scientists and we compare actuaries to quants. So both data scientists and quants have a lot more emphasis on programming in their education. And I would argue that it is the result of that focus, which enabled data scientists and quants to do better with machine learning and to do better with AI. So I do think that actuaries as a profession would benefit from a bit more rigor in programming and a bit more rigor in kind of theoretical understanding of some of these concepts. Question. So, do you think the actuarial talent being developed by SOA schools are adequate to even utilize this theoretical modern actuarial software? Uh, so yes and no. On one hand, I would say, okay, if somebody just finished school, right, would they be able to join a company and say, okay, I'm a developer in the software? Probably no. But the flip side of that, would they be ready to develop in any other actuarial software packages? And the answer is probably also no, because to do model development, you have to have decent understanding of the product. You have to have decent understanding of the software that you're using, be it be it in Python or be it in any of the existing platforms. Because in the existing platforms, you open the software and there's a lot of buttons and toggles and variables, and um, it is also quite overwhelming to a new person, and they would also need quite a bit of guidance from their employer to be able to learn and to use the software appropriately. So the reason is that PA teaches how to sling code. Coding and slinging a little logic is way different from software engineering. It is more than just coding that's important, and modeling standards are completely deficient in engineering standards. Yeah, so I agree that engineering is completely different from actually syntax. Syntax is a problem that has been largely solved by AI. You can now write a prompt and it will give you the right syntax for that. And that's actually wonderful. And even as an experienced software engineer, I like that because it's very convenient. I don't have to look up what's the name of that particular function and what exactly are the parameters that go into it. On the other hand, engineering that is indeed a discipline which is not that is not really automated by the AI. And that's why I think that having a vendor that would provide that professional engineering framework so that you kind of have an example of how everything is engineered, that would go a long way in addressing that problem, along with the support and training on that particular software. Kind of similar to what exists with existing software, where if you buy a software, you get some training on it. You know, you don't just kind of say, okay, I'm gonna go and click buttons. You can do that, but it's not very efficient. Okay, so we need more questions, please. Uh,
Can we just talk? It might be easier. Can you hear me?
yes, if you speak up a little louder.
Oh, can you hear me now?
Yes, perfect.
So what do you think about the academy um, trying to provide like an open source library that we all put together? Because one of the issues that I see with what you're saying is a lot of these companies think that when you develop software for multiple companies, you realize the only thing that is constant is that they all do it slightly differently, and that's kind of their secret sauce. So how do you kind of open up this library where and still allow companies to keep their secret sauce if assuming you kind of had this more um, open source type of thing, type of library?
Right. So I agree that each company would customize, but I think that this solution is actually would be beneficial. So if you have full access to code, right, the vendor would be unlikely to provide any bespoke functionalities, right? Because they would be more focused on general architecture and your standard functionalities that would be needed. So let's say in pension risk transfer, right? It's your projection of liabilities, projection of pensions, your deferred benefits, and that kind of thing, right? Now, I agree that each company will tend to modify this with particular capabilities that they excel at. Now, with the source available open source software, the advantage is you can develop those in-house, and by doing that, you don't even share that knowledge with any of the consultants or vendors or anybody else. So, in terms of IP protection, it is actually quite beneficial to do that. Another question is, what is your opinion on a modern tech stack being positioned with both Python and R as available tools? I think both are viable options. Personally, I would prefer Python just because it has more libraries, it has more support, it has more users, and for it's a much more common skill set. So I'm struggling to think of anything in R that you would struggle to do in Python, but there are things in R's, sorry, there are things in Python, particularly around connectivity with other tools and technologies, that would be a challenge in R. So one example would be CUDA libraries that were released by NVIDIA for Python. I'm not aware that they're available for R. Maybe they're available by third party, but not by NVIDIA itself, right? Um, but that being said, for majority of what actuaries use, I think either could be a valid option.
So, what do you think the path forward is? If we were to put it on the path where we could actually get to your dream idea, what would be the steps or the starting steps to put us in that direction?
So there would need to be a company that provides this software. Um, and I actually happen to work at such a company. Um, but we are very narrowly focused. We're focused on just PRT and LRT at the time, at this moment. Expanding this to the rest of the products will take some time. Do you have any hot take on Julia language as an emerging competitor to Python for actuarial modeling? Yes. So Julia is a very interesting language. It is out of the box a lot more performance than Python. And in fact, Python without libraries like NumPy, it is not very performant at all. So Julia has an advantage of saying, okay, if I'm not going to use a lot of libraries and I want something hyper performant, and I want something that is a bit that is very focused on kind of efficient calculation, then Julia is quite good. The risk you run with that is one, you would have to find Julia developers, and those would be a little bit more scarce. Well, they'll be a lot more scarce than Python developers. So you would have to train most likely Python developers to use Julia. Um, and Yeah, that would really be the biggest drawback. I'm not very knowledgeable on how many libraries does Julia have for things like visualization and data connectivity and like AI integrations, machine learning, etc. If those exist and they are well supported and free, then that's probably not a big consideration, but that would be something I would definitely consider for any of the languages. Does it have the libraries that I will need for my specific use case? Okay, so we have time for another couple of questions. Anybody else?
One thing I didn't hear you talk about like, or maybe you did, was about having this vision and using like DevOps tools. Like one of the major problems with using the proprietary, let's say Profit Access or whatever, is that you can't use, they're not meant for using Git and they're not using for DevOps tools, which are very standard in a software engineering perspective, which would
Mhm.
allow governance to be way easier. So how does this kind of fit into that?
Yeah, I agree. When I was talking about standard tools, I listed a couple of examples like Visual Studio, but yeah, absolutely, Git, DevOps. There's one, no reason not to use them. Two, to your point, it will put governance on a whole next level because you can have unit tests, you can have pipelines that enforce the quality control. You have a lot of libraries that enforce even things like style guides and like your variable naming conventions. And it is far more advanced and far more convenient comparing to the similar interfaces and tools that I've used in a proprietary software. Um, so it would indeed integrate with all of those just because those are indeed the best solutions for those problems.
Just to comment, that's where I find that a lot of the tools that we have as actuaries fail is in governance. So you make it easy for the actuary, let's say, to program in one, but then you make governance nightmares because now it requires you to have a whole bunch of redundant code because you can't do any type of abstraction. Modularity is hard, and all these things. that you would have in a software domain to manage it, you don't have. And so then that immediately gets squirted out to governance. So you have to have these huge governance structures around the coding, or you have tons of model risk management, and you really have no way of working with that. So I don't know. Comment more on the
Uh,
question.
what if a vendor solution came with few thousand unit tests out of the box that are that basically test all of the standard functionalities that you would have, right? So what that would do is, let's say every time you do a model change, you would have a very quick way to check whether you broke anything, first of all. And it would be programmatically enforced when you try to merge code to say, okay, if you broke something, it just won't merge. You have to go and identify what you broke and how. I would, I think that that would help a lot with governance. And there is only once in my career I've seen a tool with it had about 6 million tests to it. So it was extremely well tested. But most of the other times, the existing actuarial tools, on one hand, we say that yes, there is governance, right, because we can't touch it. But on the other hand, have I found mismatches between like documentation and what the tool actually does? Yes, I have. Um, have I have I seen vendor solutions that only had of tests for new functionalities that was developed for them? Yes, I have. So I don't think that it is a problem unique to tools that provide access to code. But I do think that providing access to code, especially if the tool is professionally engineered by a vendor and has a good structure, it would alleviate a lot of those problems, as well as coming with a well-developed test bank out of the box would be very helpful. Okay, and with that, I believe we are at time. So thank you, everyone. Thank you to the live audience. And thank you. Have a good day.